can you please try first, number 3? Did anyone say anything? Right. Okay. Okay, I'll give you 3 minutes, right, to answer the questions. Okay, we call 3 students to answer this question. Okay. Okay. So I will call names. Jia Shun. Kung Jia Shun. Okay, can you give me the answer? Kun Jia Shun. What's your answer? Hello? Jiaxun. No answer. What's the answer for this question? For 3A. What is the answer for 3A? Okay, Zian, give Jiaxun to answer first. What's the answer, Jiaxun? 8,000. Okay. Right, are you sure 8,000? Okay, let's read the question. So in a jungle trekking activity, a scout is given a compass and a map. Okay, so he starts his journey from station A and is required to walk to station A. So means the distance from A to B is 400 meter. Okay, and then when he reached station B, he is ordered to go to station C, which is 400 meter not from station B. So 400 meter from B to C. Okay, and the next question is said when the scout is at station C, what is the distance he travel from station A? So for distance, we just only total up all the length that he's traveled. Okay, so means 400 plus 400. So you will get 800 meter. Okay. Alright, the next one is what is the scout displacement? Okay, from station A. State the magnitude and the direction of the scout from station A. Okay, for this question, alright, displacement, okay, I already told you displacement. What does it mean by displacement? Displacement is the shortest distance, right? Shortest distance travel in the certain direction. So let's say the scout wants to go from A to C. So means the shortest direction is here, right? For on this part. Okay. So use theorem Pythagoras. Okay. So 400 square plus 400 square is equals to AC. So AC is, okay, AC square, sorry. Okay, then you have to find AC, okay, the length of A and C. So just use your calculator. So you will get 56 565.69. Okay. So 565.69. Okay, that one is a displacement, but don't forget displacement you must include the direction also. So the direction is to the north east. Okay, to the north east. Okay. Okay, for B, why does the answer in 1 and 2 are different? Why is different? Why the 1 is 800 and 2 is 565.69? What is the reason? Answer 1 is further because the scout reached point C by passing through B from A, whereas answer in 2 is shorter because the scout goes to point C directly from point A without passing through point B. Okay, so actually the simple one is why does the answer in 1 and 2 different? Okay, what is the actually distance? Distance is what quantity? Displacement is what quantity? Okay, this distance is a scalar quantity while the displacement is a vector quantity. Okay, so that's the answer. Okay, so distance is a scalar quantity. Okay, scalar quantity while displacement is vector quantity. Did I left? Did anyone see I left the Google Meet?
No, teacher.
Alright. Because someone texted me said that is it keep on showing me left. Someone text me say I keep left the Google Meet. No, right?
No,
Okay,
teacher.
so tell me if I keep no, right, alright, okay. Thank you. Okay. Alright, so next we move on to the speed and velocity. So you already now know the difference between distance and displacement. Okay, so now we go to the speed and velocity. Alright, so speed or velocity I used to describe how fast a car is moving. Okay, this one is actually on your car dashboard there. They see the speedometer there, right? They will show you, okay, what is your speed, what is your velocity, but this one the unit is in kilometer per hour. Okay, how is velocity different from speed? Okay, so and move. Okay, this one can you change it to speed? Okay, and this one change it to velocity, right? Okay, the first one is the meaning of speed and also velocity. Okay, so speed is the rate of change of distance. So you can see here speed they use a distance. Okay, while the velocity is the rate of change of displacement. Okay, means you use the displacement to calculate the velocity. So it's different. Okay, like the before we did the questions, right? You can see the value of the distance and displacement also uh, is different, right? This one, the distance, the value is 800, while the displacement, the value is 565.69. So if you use the value of distance to calculate the speed, it will be different if you use the displacement to calculate the velocity. Alright, so that's the difference. Okay. Right. And then the next one is the unit. The unit is same, meter over second or ms negative 1. Okay. Alright. The only difference is that one is have a direction and the one doesn't have a direction. Okay. And then the next one is a derived and scalar quantity. Okay. So both is derived quantity because it consists more than one of base quantity, right? Meter second. Alright, so means it consists more than one of the base quantity, meter and second. So we call it as a derived. Alright, and this speed is a scalar quantity, okay, and the velocity is a vector quantity. So mean it will involve the direction here. Okay, and then the formula, speed is distance divided by time, while velocity is displacement divided by time. Okay, so are you clear about the difference between speed and velocity? Any questions? Any question you want to ask teacher? No. Okay, if any question, just ask in the chat, okay, or you can open your mic, okay? Alright, so this is supersonic car, okay? So the fastest speed on the land is 1220.9 kilometer per hour. So this speed is achieved by Andy Green, which drove his supersonic car, Trust in Black Road Desert, right, Nevada, 1997. So this speed is faster than the speed of sound. So actually the speed of sound is 340 m/s. Okay, so this one is 1220.9 kilometer per hour. This one is faster if you compare to the sound. Okay, sound only 340. Okay, this is only for your knowledge. Okay, now we move to the average speed. Okay, so what is the formula of the average speed? Average speed is a total distance divided by total time. Okay, since you already know speed, they must use a distance. Okay, and velocity, you must use a displacement. Okay, so this one is a scalar and this one is a vector. Okay, alright, the next part is uniform speed. Okay, so what is a uniform speed? So means the speed that remain the same in magnitude regardless of its direction. Okay, so let's say if I have when I drove a car, okay, so I drove a car, let's say I drive 50 kilometer per hour, okay, and then I turn back my car, okay, and I still move with 50 kilometer per hour. Okay, even the direction is changed. Because speed, you know, is a scalar quantity, so the direction is not considered. Okay, we didn't consider about the direction. We only considered about the magnitude because speed is a scalar. Okay, and the magnitude is same, right? It's 50 kilometer. So we can call it uniform speed. Alright, and uniform velocity. So velocity that remains in same in magnitude and direction. Okay, so for velocity, you have to consider the direction since it's a vector quantity. So for this one, means this one is not a uniform velocity because the direction change. Even the magnitude is same, but the direction is changed. So this one is not a uniform velocity. So for uniform speed, only consider about the magnitude. Okay, so it doesn't matter where's the direction, okay, uniform speed, but for uniform velocity, you have to consider the magnitude and also the direction. The direction must not change, okay, through all the time given. Alright, so this one is not uniform velocity, but it's a uniform speed. Okay, so are you clear about you need to ask teacher? You want teacher to explain again? You want teacher to explain again? Okay. Alright. I'll give you another example. Okay. So let's say this is Ali. Okay. Ali run, okay, like say 10 meter per second. Okay. Then after he reach at point B, okay. So let's say this is A, this is B. So Ali start run from A to B, 10 meter per second. Then after that it turns back, okay. Okay, and it still run with the same speed, 10 meter per second, okay, but in different direction. Okay, so the first one, okay, is it uniform speed? Yes, it's a uniform speed because the magnitude is not changed. You can see it run with the same speed, right? 10 meter per second, and then when it turns back, it's still 10 meter per second. Okay, even the direction is changed, but the magnitude is not changing. The magnitude means the value here, still 10 meter per second, right? So the magnitude is not changing. So this one we call it as a uniform speed. Okay, if you consider only the magnitude. Okay, alright, so let's say if asking you, is it move in the uniform velocity? No. Why? The magnitude is same. Okay, when it turn back, it still run with the same speed, 10 m over s. Okay, but it's different direction. Why? Because the velocity is a vector quantity, right? So vector quantity, you must consider the direction. You can see here the direction is changing, right? In opposite direction. Okay, so means this one, the velocity is not uniform. Okay, this one uniform speed, but non-uniform velocity because the direction is not same, or you can say is opposite. Okay, are you clear? So teacher, we can calculate the velocity if the direction change. Okay, you can calculate the velocity, alright? But let's say for this one, you cannot calculate the velocity. Why? Because if you calculate the velocity positive 10, right? Because it moved the displacement, right? So what is the velocity formula? Velocity is displacement divided by time, correct? Okay, for this one, displacement is when you move positive 10, then you move backward negative 10, right? This one should be negative, so you will get 0. Okay, so means the velocity is 0 ms negative 1. Okay, alright. But for, let's say if I give you example like this. Okay, it moved 10 meter per second. Okay, and then for this one, okay, and then this one, let's say the distance is, wait, I give you another example. If you want to calculate velocity, right? Okay, so let's say it move here 50 meter, and then it move back 5 meter, okay, in 20 seconds. So let's say this is the question. Okay, so how you want to calculate the velocity? So when you move forward, it's a positive 15, right? So when you move backward, it's a negative 5. So positive 15, negative 5, you will get positive 10. Okay, so 10, and then you already know the formula is displacement divided by time, right? So 10 divided by 20, you will get 0.5. So this one you can calculate. Okay, for the velocity. But for this one, you can calculate, but the value is 0 because it's come back to its original position. Okay, is it okay? Ketiga. We can calculate, but you have to find the displacement. Okay. Any other questions? No, teacher. All right. Okay. All right. So let's see the first example. Okay, world record holder for 100-meter man event is held by Usain Bolt. Okay, with 9.58 seconds. So calculate the average speed. Okay, so speed. Okay, so what is the formula for average speed? Okay, for physics, train yourself, okay, to put a formula before you calculate something. Show your formula. What formula you use? Okay, so average speed is a total distance divided by total time, right? Total distance divided by total time. Okay, so the total distance 100 meter. Okay, and then the total time is 9.58. Okay, so just use calculator. 100 divided by 9.58. You will get 10.44 ms negative 1. Okay, so that's how you calculate average speed. Right, very good. Okay, very good. Okay, so next part. Okay, an object has a non-uniform velocity if the magnitude of velocity is changing, okay, and then the direction of motion change or the motion is not straight line. Okay, this one I already explained. For you to call the velocity is uniform or not, you have to consider two things, magnitude and direction. Okay, so if a uniform velocity, the magnitude and the direction should be same. Okay, should be same. Means if the object travel to the left, it will keep move to the left, right? And also the magnitude should be same. If we move with 50 meter per second, it will move, it still move 50 meter per second and without any change. Okay, so you can call that, if that's happened, we can call that the object move with uniform velocity. Okay, so uniform velocity, I make a summarize here. Uniform velocity, magnitude, direction, same. Okay, for uniform speed, we only consider the magnitude. So the magnitude is same. Okay. So we just we just ignore the direction, whether it move to left or right, as long the magnitude is same, that one is a uniform speed. Okay, so I hope you are clear, you can differentiate between uniform velocity and uniform speed. Okay, so let's try to answer this question. So you can see it move in the opposite direction, right? Okay, so try to answer this one. Is the velocity, is the speed same? Is the velocity both cars same? Okay, so please answer this one. Okay, anyone want to answer? Speed is same. Okay, then how about the velocity? Speed remains same, good. Velocity is same too. Speed is same, velocity also same. Are you sure? The velocity is same. Can you see the direction of the car moving? Okay, I let you see again. Can you see the direction? I already told, yeah, for I already told you. Okay, for velocity, you have to consider the magnitude and the direction. Alright, the velocity is different. Okay, for the speed, okay, both move with the 80 kilometer per hour. Okay, both move with the 80 kilometer per hour. So means speed is same. Okay, even the direction is different, it doesn't matter because speed is a scalar. We don't consider the direction. Okay, speed is same. Okay, and you already see, okay, the car move with opposite direction, right? Okay, so this one, if the velocity same, no, velocity is not. Velocity is different because of what? Because you can see even it move with same magnitude, but it move with different direction. Okay, so velocity is not same. Velocity is different. Okay, since the direction is in the opposite direction. Okay, are you clear why I said velocity is not same? Are you clear why I said before this? Some of you said the velocity is same. Okay, it's not right because of the direction is not same. Okay, just now I misunderstand the question. Oh, okay. For E didn't give any response. Mostly for S give the response. For E, are you sleeping or what? Okay, at least one people answer. Okay, next we go to the meaning of acceleration. Okay, so what does it mean by the acceleration? This one actually you already learned in Maths Form 3. Okay, so acceleration is the rate of change of velocity. Okay, so this is the meaning. Okay, for physics you have to remember, okay, the meaning of the terms. Okay, they say for just now we learn about velocity, so you have to know what's the meaning of velocity, what's the meaning of speed, what's the meaning of what is the meaning of distance, what is the meaning of displacement, okay, what is the meaning of acceleration. So all of that you have to know the meaning, okay, the meaning of the term, because in exam there will be like 5 questions or sometimes more, okay, asking you about the meaning of each term, okay. So later I will give you the list of terms that you need to remember for Form 4 and Form 5. I will put in the GC, okay, in the Google Classroom, you can download there. Alright, I will not print it out, okay. So you can, if you have a printer, you can print on your own, okay. Alright, so the first one is the acceleration is the rate of change of velocity. Okay, what is the formula? Okay, so formula is the final velocity minus with the initial velocity, and we divide it by time. Okay, so this is the symbol for, this one should be V, right? Not U. Okay, they put it wrongly here. This is V and initial velocity is U. Okay, right? Then this is the formula. Okay, final velocity minus with the initial velocity, you divide by time. Time is actually the time taken, okay, for the change of velocity from initial to the final velocity. What is the time taken, okay, from the final time taken to reach from initial velocity to the final velocity. Okay, I will give you an example how you want to calculate. Okay, like this, let's say for this question, okay. So a bicyclist starts from rest. So mean from rest, its initial velocity should be 0. Okay, U is 0. Okay, and increases his velocity at a constant rate until he reach a speed of 4 meter per second. Okay, so it keeps cycling until it reach 4 meter per second. So mean 4 is actually V. V is 4.0. Okay, how many seconds it takes time to change from 0 to 4? Is 5 seconds. So means T is 5. Okay, and then the question, what his average acceleration? So this one you have to take out, okay, all the value given, all the information given in the question. So state the initial velocity is 0 ms negative 1. Okay, state the final velocity V is a 4.0 ms negative 1. So state the time taken. The time taken is 5 seconds. Okay, and then calculate the acceleration. The acceleration, the formula is A is V minus U divided by T. Okay, so already give you all the info there, V, U, and T, so you can calculate. Okay, so V is 4, U is 0, time is 5 seconds. Okay, and then you just use your calculator. 4 divided by 5, you will get 0.8 ms negative 2. Remember, this is the unit for acceleration. Okay, don't put ms negative 1. That one is for velocity or speed. Okay, so please remember the unit correctly, because starting in KSSM, okay, they have to consider the unit. Before this, on paper 2, we didn't consider the unit. Let's say you give the answer 0.8, we still give you mark. Okay, but in KSSM, okay, you have to put the correct unit and also the correct unit. Okay, so make sure you know all the unit for each physical quantity. Okay, so are you clear about question number 5? Anyone want me to repeat again how to calculate the acceleration? Yes, teacher. Yes, you want me to repeat or you are okay? You understand? Oh, okay. Okay. Okay, zero acceleration. Okay. Just now we already learned uniform velocity, uniform speed. Okay, uniform velocity means the magnitude of the velocity is not changed. Okay, and also the direction is also not changed. But for speed, we only consider about the value, the magnitude. Okay, as long it's not changed, we say is uniform speed. Okay, now we go to the zero acceleration. So what does it mean by zero acceleration? Okay, so let's say an example. Okay, I drive a car, okay, in 1 hour with 50 kilometer per hour. Okay, means in 1 hour, okay, my velocity is 50 kilometer per hour. I'm not changing my velocity. So means my acceleration is zero. Okay, there is no change in velocity. Okay, so that mean zero acceleration. Okay, or you can say the object is at rest, means it's not moving at all. Okay, that one also we call it as a zero acceleration. Okay, or the object move with constant velocity, means constant velocity means the object move with the same velocity. Okay, throughout the time. They say 1 hour, I drive 50 kilometer for 1 hour. I didn't increase it to 60 or I didn't decrease it to 40. Okay, maintain 50 kilometer per hour for 1 hour. Okay, that's the meaning of zero acceleration. Are you clear? What does it mean by zero acceleration? Means there is no change in velocity. Anyone want me to explain again what does it mean by zero acceleration? Okay. Next, we goes to the constant acceleration. Okay, so constant acceleration, velocity increases at a constant rate. Okay, so means let's say 1 second at the when the t is 1 second. Okay, and then when the t is 2 second, my velocity is 20 ms negative 1. When t is 3 second, okay, when the time is 3 second, my velocity is 30 ms negative 1. So you can see it increase, right? It increase in the same, okay, same number, 10, 10, 10 like that. So means the increase at the constant rate. Okay, so you can see increase 10, 10, 10 here. So mean it move with the it increase in a constant rate. So this one we call it as a constant acceleration. Okay, constant acceleration. The velocity increase in a constant rate. Okay, so if t4, my velocity is 40. Okay, so it increase in a constant rate. Every second it increase 10 ms negative 1. Okay, every 1 second is increase 10 meter per second. Another 1 second increase another 10 ms negative 1. So you can see it increase in a constant rate. So we call it as a constant acceleration. Okay, and the example when a car move at a constant acceleration 5 ms negative 2, its velocity increase 5 meter per second for every second. Okay, so let's mean if I say the car velocity the car move with 15 ms negative 2, constant acceleration 15 ms negative 2. So what does it mean? This means for every 1 second, okay, the car increase its velocity in 50 meter per second. So means another 2 second. If 2 second means will become 30 ms negative 1. Okay, if 3 second it will be 45 ms negative 1. So this one is the constant acceleration. Means for every second it will increase in constant rate. Okay, so are you clear about the constant acceleration? Anything you want to ask teacher? Okay. Right. So this is the notes. Constant means also you can put it as a uniform. Okay. Increasing velocity means the object accelerate. If decreasing velocity means decelerate. Okay, increasing velocity, example, the initial velocity is 10. Okay, and then the final velocity is 20. So you can say this object is accelerate. Okay. Okay, let's say for decreasing acceleration, if u is 20 and then the initial velocity is 20, then the final velocity is 10. So you can see the velocity is decreasing. So we call it as a deceleration. Okay, zero velocity means whether the object is at stationary, means it's not moving. Okay, 0 ms negative 1. Okay. Alright, for the negative velocity means the object move at opposite direction. Okay, because velocity is a vector, right? So you have to consider the direction. Okay, let's say I give you an example. So I have a ball. Okay, then the ball hit the wall. So and then the ball will be bounced back, right? So for this one, let's say my velocity, the initial velocity is 10 ms negative 1. Okay, so when it bounce back, the v, the final velocity, you have to put negative, right? Because it moved in the opposite direction. So negative 30 ms negative 1. Okay, so it moved in the opposite directions, you have to put negative. Okay, so this what is it mean by negative velocity, because it changed direction. Okay. Alright, and then for number 6, zero acceleration means constant velocity. So this one we learn later when you do 2.2 motion of graph, we will learn more about this one. And the negative acceleration means deceleration. Okay, so this one is okay, we learn later 2.2. Okay, more about this one. Okay, this is the term that you need to know. Okay. Alright, so I will stop my class now. Okay. And you can see there is an exercise here. Okay, I want you to do 1 until 6. Okay, so we still have a time like 15 minutes more. So I want you to do question number 1 until number 6. Okay, and for the notes, I will try my best to put today at the guide for those who cannot print. Right, so if anything, I will update you in the group. Okay, I will take a picture to show which box I put the notes here. Okay, because after this, I will check whether they already photocopy or not my notes, because I sent last week. Okay, so and for those who already have a note, you can complete your note. Okay, so this is your homework. Okay, Chinese New Year holiday is 5 days, right? Okay, but so happy holiday. Okay, for those who didn't celebrate, okay, take care yourself. Okay, even it's a Chinese New Year, okay, don't forget you do revision, do your homework. All of you got your number, got my number. Okay, so thank you class. Okay, so this is your homework. You can do it during 50 minutes. We still have 50 minutes more. I don't want to move to another topic because there's a lot for you to already, right, to learn today. I'm afraid that you will be confused later. We will stop until that only. Okay, so thank you. See you next week.
Thank you, teacher.
Okay, alright, welcome.
Thank you,
Thank you.
teacher.
Alright, happy
Thank you,
Chinese New
teacher.
Year, class.
Bye, teacher.
Bye bye. Take care.